We are finally back to the Spring Boot server we set up initially. The code here is pretty simple as well. The WhatsApp application is the boilerplate main class of the Spring Boot project. There isn't much here, and I'm only mentioning it for completeness. Security configuration is a bit more interesting, although again it's similar to what we saw in previous projects. First, we need to permit all requests to remove some HTTP security limits. We don't need them here since this isn't a web app. Similarly, we need to disable CSRF protection as it isn't applicable for native apps. Finally, we need to provide password encoder implementation. We use this to encrypt the tokens in the database. Next, let's go into the entity objects. I won't go into what entities are, as I discussed them a lot in the previous modules. They are effectively an abstraction of the underlying data store. The user entity represents the data we save for a chat contact. I use a string unique ID with a universal unique identifier, which is more secure as I mentioned before. It might make sense to use the phone as the ID value though. The username and tagline are also stored similarly to the client-side code. Phone is listed as unique, which makes sure the value is unique in the database. When we send a verification code, we store it in the database. I could use a distributed caching system like Redis or Memcached, but they're an overkill for something as simple as this. The date in which the user entry was created is a standard database date. This isn't used at this time, but it's very similar to the code we have in the Facebook clone to store media. In fact, it's copied from there and we can refer to that for media storage/upload. The auth token is effectively a combination of username and password. As such, it's hashed, and as such, only the user device knows that value. I believe that's how WhatsApp works. That's why only one device can connect to a WhatsApp account. Since the token is hashed, when you need to retrieve an access token, you need to effectively delete the last token and create a new one in order to set up a hash. For the uninitiated, a hash is an encrypted value that can only be generated but not retrieved. So if my password is password and the hash is XYZJKL, then I can get the value of the password from the hash, but I can check that password matches XYZJKL, but not vice versa. Hashes are also salted, so they have 60 characters in length, and strong hashes are impossible to crack with standard tools. The push key is the key used to send push messages to the client device. This flag indicates whether a user is verified. When we create a new user, we initialize the ID and creation date sensibly. If this entity is loaded from the database, these values will be overridden. The DAO methods create data access objects that we can send to the client. We will make use of them later in the service code. The user repository maps to the user object and exposes three finder methods. We use find by phone during sign-up and sending to detect the user with the given phone. This method should be removed as it's part of the copy and pasted media entity code. We need to find the push by push key in order to remove or update expired push keys. If the server returns an error, we need to update that. UserDAO is pretty much the content of the user class. There isn't much to discuss here, with one major exception, and that's the JSON format annotation. Here we explicitly declare how we want the date object to translate to JSON when it's sent to the client. This is the standard JSON pattern, and codename1 in the client side knows how to parse this.